talk is typically sold to people as connecting data to value. But of course, that's what everybody wants to do. It's a little more difficult than that. So the actual talk is called Connecting Data Decisions to Value. And it really is about selling executive management on the importance of data management concepts. My name is Peter Aiken. I've been doing this for a very long time. I'm an associate professor at Virginia Commonwealth University. I own a company called Data Blueprint, and I'm the past president of DAMA International. I tend to speak a lot and work with a lot of different groups, so I have a couple of things I've managed to put together over the years that hopefully this will be helpful. First of all, most of the time when you see this type of a process explained to people, they give you something like a very good data value chain here. But I want you to try and remember that most organizations haven't had the maturity to be able to execute something like this very, very efficiently and effectively. And so while this is a great roadmap, we also need to pay attention to how to get to be able to do this in the first place. Another part of it is it's not an easy sell when you try and show them something that looks like a worm. I'm kidding about the worm. The real question is, help your organization first to understand that your basics of what you do in your organization are data. Management creates plans, the plans are communicated downwards, and people do things in response to the plans and directives. Sometimes some organizations actually make something. But for the most part, your organization is all about data until it's not about just data, and some organizations never get to that last line. It's important to think, what business are you in fact in, and then look at it from that perspective. Now, what we're going to do here today is take a little journey in 3 phases. The first phase comes in with sort of where everybody is, and measurements. This is what we do. Measurements show that most organizations are still at capability level 1, which means their data is considered to be a byproduct of IT, managed by IT. Another word for something that's treated this way is detritus. So I like to start out with a little acknowledgement. Most people are not aware that the first programmer in the world was a woman named Augusta Ada King, or as she was more popularly known, the Countess of Lovelace. Ada Lovelace, she was the publisher of the first computer program, and I'll show you that in just a second. But more importantly here is a saying that she wrote where, well, just read it. In considering any new subject, there is frequently a tendency first to overrate what we find to be already interesting or remarkable, and secondly, by a sort of natural reaction, to undervalue the true state of the case. By the way, here is her computer program, but that's not what we're going to talk about. We're going to talk about something that Gartner now has relabeled the 5-phase hype cycle. Everything starts off, interestingly, with a technology trigger, and it goes to the peak of inflated expectations. Early success stories, often accompanied by failures. Some companies adopt, some don't. Then we go to the trial of disillusionment. You see the pattern here. It really great, it really sucks. Well, the answer, of course, is that it's somewhere in the middle. We only find out where the middle is and what it looks like by going up the slope of enlightenment, eventually to end up on the plateau of productivity. Now, I show you this, and again, I'm going to do it one more time. Technology trigger. Right, peak of inflated expectations, everything's great. Trial of disillusionment, well, it wasn't all that great. Up the slope of enlightenment, well, we're learning how to work with this in trade-off against our other things that we work with, to the plateau of productivity where we've kind of got this. So let's take a look at a couple of Gartner cycles. First one here is 2012. July of 2012, text analytics, if that's where you were, was about to experience the bottom of the trial of disillusionment and start to move up the slope of enlightenment. So if you're in text analytics in July of 2012, that's terrific. If you were in social network analysis, you were about to go over that peak of inflated expectations. Gartner's actually pretty good at this, which is one of the reasons people like to pay attention to what they say. And, you know, as of 2012, predictive analytics and web analytics were in pretty good shape. So let's move on to where big data was in 2012, and it's right there in the green. Big data, notice, is in a sort of light color blue as opposed to the dark color blue that there. And that light color blue, if you look at the bottom, is a 2 to 5 year cycle away from actually being at the plateau of productivity. Next year, 2013, big data had moved up, but notice the color of the indicator had changed from 2 to 5 years, in this case to 5 to 10 years. So just in 1 year, they had doubled the amount of time that it was going to take to get to the plateau of productivity. Talk about a big change in expectations. This is one of the most notable things about big data. Now in 2014, it's gone over the top of the cycle, and it's now headed for the trial of disillusionment. And probably some of you remember those days. Once again, 5 to 10 years still, even though it's gone over and it's been a year, it's still 5 to 10 years out. So we're seeing increasing amounts of hype and imprecision around this topic at all. And by 2015, Gartner had actually taken it off of the hype cycle because they wrote instead a report, The Demise of Big Data, Its Lessons and the State of Things to Come. It's out there on the web. You can look it up. What they said was people are integrating these big data technologies into their processing environments, which is kind of the plateau of productivity, but it was not as measurable at this point. So you can take a look at that report at your leisure on that. I was in at Columbia recently, and they had a interesting piece that they were talking about as well. You know, what is going to be the next level with big data? Well, they said gigantisco data, humongous data. Again, it's problematic. If we have no objective definition of big data, then any claims, any measurements, any success, any quantifications, anything at all must be viewed skeptically with suspicion because everybody thinks about it differently. Same problem with the data science. Famous quote by the fellow who's actually credited with inventing the predictive analytics field, Eric Siegel, says data science is a redundant term. It's like calling somebody a book librarian. All science involves data, and therefore it doesn't work. Now, if you want to get to the right level of abstraction, then I would qualify this and say a animal data scientist or molecular data scientist or a biology data scientist. Now you can start to talk about things that are useful, but our current concept of data science is way high at a level of abstraction. In order to be more useful, we need to get more domain specific and more creative with our programs. It's another interesting part of all this too, which is garbage in, garbage out. Now, I'm just using blockchain here as an example, mainly because whoever put the slide together did it as well, but it's very good. Poop in, chocolate ice cream in. Awesome thing. You still get chocolate ice cream on the way back out of it here as well. If you substitute blockchain or anything else awesome in there, you still have the same problem. Garbage in, garbage out. In fact, it's a little more complex than that. It's garbage data in a perfect model gives you garbage results, and perfect data in a garbage model also gives you garbage results. So you need to get both the data and the model perfect in order to do this. And part of our problem is that we've been teaching people badly about this. Again, I say this as a university professor, but we teach them in the curriculum that these things are the components of systems. People, processes, hardware, software, and data. Problem is, data is really different, and if we don't start paying attention to those differences, it will be problematic. Just to give you an example of data issues, every minute of every day of the entirety of 2017, Netflix managed to cram almost 70,000 hours of streaming data into every minute. These are some other items they had up here. There were also a million Tinder swipes left or right every minute of the entirety of 2017. Yeah, we're talking lots and lots of data. And a good way to work with people and get a good understanding about data is to adopt this wonderful quote by our friend Micheline Casey here. There will never be any less data than right now. And that's not true over everything else. There will be more of them, yes, of course, but what's really happening here is an increasing volume of this new type of thing that we no longer should consider detritus, and in fact should start to think of as more of a resource. That's our next step, because it's a complicated subject. It's taught fairly inconsistently, and it's poorly understood, and nobody outside of the data community wants to talk to anybody in the data community about it because of these details, but it is nevertheless a crucial importance. See, unlike engineering failures, data engineering failures are a little different. So let's take a look here. The Tacoma Narrows Bridge, also known as Gallopin Gertie, was opened on July 1st of 1940 and collapsed just months later on November 7th on this. Now, if I had a Coke can, in fact I do, that I take the tab and you guys all know that sound. That tab is a piece of metal being snapped off. And if you look at this bridge, of course, it does not look as if this bridge was built to do these things. Of course, it was not. And consequently, as you might imagine, it is in the process of breaking. Now, interesting side note, the insurance company that had to pay for this failure of engineering was the company that filmed this so they could learn more about what had happened. And they did learn from this. They changed the way their approach to engineering was. Data failures are not this obvious. They are insidious, in fact, and they go in tiny, tiny cuts and consume 20 to 40% of your IT budget, which is an enormous, enormous amount. I mean, take a look at some numbers here. Sorry, I'm going to go back. There we go. Take a look at some numbers here. Quintillions of queries that are being run on a daily basis. If something adds up a lot, and here's a query. It's a fairly complex query, and this organization had never heard of optimizing the query, which makes it easier. It doesn't make it easy, but I don't know about you. Hopefully you can see that this is more work than this is here, regardless of whether you understand the query language or anything else that's going on. And to multiply that to millions, tens of millions, hundreds of millions, billions, enormous times each day, it creates this death by 1,000 cuts. And these death by 1,000 cuts hurt organizations over and over and over again and spend 20 to 40% of their IT budget evolving their data, migrating it, converting it, or improving it, but they're not doing it as efficiently and effectively as they should. This leads to what I call the bad data decision spiral, where business decision makers and technical decision makers are not data knowledgeable. This leads to bad data decisions, poor treatment of organizational assets, and poor organizational data quality. We've got to do better than that. Doing a poor job with data takes whatever you're doing longer. Doing a poor job with data costs more. Doing a poor job of data delivers less, and doing a poor job with data presents greater risks. By the way, that's all attributable to Tom DeMarco, a wonderful, wonderful pioneer in the field here. So this detritus we've got to get away from and move our thinking to the next capability level, which is a level 2 organization. In this case, data is perceived as a resource, and you'll notice it takes appropriately more time and more money, but delivers more potential value as well. See, organizations simply don't know what data they have, they don't know where it is, and they don't know what their knowledge workers are doing with it. Consequently, it's very hard to be efficient. They've all had to learn this stuff on their own. When you look at organizational readiness, you'll see that it takes all of these 5 components lining up to make something actually work. In this case, if I see frustration in an organization, starting on the right-hand side, they've got an action plan, incentive, skills, vision, but what they're missing are the resources. Similarly, if I see anxiety, I see vision, incentive, resources, and an action plan, and missing the skills. This is from a change model by Mary Lippert from 1987. Many, many people use this. It's a wonderful way of looking at these things. And as I said at the top of the slide, only when you have a combination of vision, skills, incentive, resources, and an action plan can you in fact expect organizational change. And culture has been, continues to be the biggest impediment to shifting our thinking in organizational data change pieces. And change leadership is a professional division that we should take use of. These guys are wonderful, and forgetting to do this is just as bad as forgetting to market your program. I have a case study. You can QR that code or click on the link wherever you happen to get this and download a copy of the paper that describes a little bit more about all of these things. Now, organizational assets, most people would be pretty easily coming up with a list like this, and they don't think that data is a part of that, though, and that is something we need to change our thinking, because data is today's most powerful, underutilized, and poorly managed organizational asset. It's the only asset that you have that is non-depletable, non-degradable, durable in nature, and strategic in nature. And as an asset, when you compare that against other assets, it has properties that the others do not. It is a unique type of asset. Most people then go straight to a very interesting conclusion. Data is the new oil. If you Google this phrase, you will get more than 5 million hits on this. But I don't think this is a good way to think about data, because oil is a production function. And we put it out of the pump and into our tanks, and we use it once. Data inherently is a reusable function, and it needs to be thought about with a different metaphor. So when I see this oil, I go up on the board and I just add an S to it. Now, If you're a gardener, you know that this brings two dimensions into it that are different already from our production function. First of all, is that you don't just randomly walk around the yard and throw seeds. And secondly, you take time. You don't expect to plant things on Monday and eat them on Friday. There is a growing season that has to occur. And everybody's aware of that season, and people don't have unrealistic expectations about it. So both of these work very well, transforming our thinking around data as a resource. If you want to call it the new bacon in your organization, that works great. The goal is to really say that as such a unique asset, it deserves its own strategy. Data deserves attention that's on par with other organizational assets and professional administration to make up for past neglect. An undesirable characteristic of data, however, is that we'll all agree that data that is better organized increases in value. Again, would you rather have a book with the pages in random order or the pages bound in the correct order? Poor data management practices, therefore, are costing organizations money, time, and effort, and 80% of the data in your organization is rot. The only argument I get on this statement is that it's not 80%, it's 85%. It's 90%, some organizations have claimed. Now, rot is a term that stands for data that is redundant, obsolete, or trivial. Why would you maintain dual copies of it? Of course, remember, if you don't know what it is, what your people are doing with it, or how it's located as an asset, you are going to be unable to actually make use of it anyway, which is why there's so much rot out there. My wife, by the way, corrected me and said it's a riot, redundant, incomplete, obsolete, or trivial. Okay, she's correct. Now, the idea is data is chopped up into pieces, and that's why we have so many copies of it, and so much of it is of an unknown characteristic, because data is attempted to be managed as a project. You cannot manage organizational data as a project. In fact, what you need to do is tie in management's mind the idea that your data program must last at least as long as your HR program. Nobody says, oh, we're done with HR, right? We've got that one all taken care of. We're not going to ever need HR professionals anymore. See you guys later. Bye. This is, of course, the attitude that many organizations, not understanding what data does, have about their data management programs as well. Data is not a project. It's a durable asset. It has a life more than 1 year, and it's reasonable to expect project deliverables for projects in 90-day increments or 2-week sprints. I don't mind. But data evolution has to be has to be measured in years. Data evolves then. It is not created. It operates at a pace that keeps it as an asset and as an asset class significantly more stable than other types of assets. Think of the technology changes we've gone through. Ready-made data architectural components are simply a prerequisite to agile development, and if you're in the middle of an agile sprint and you find out your data requirements are wrong, then you will create another small pile of data. No problem. So the cadence is important. IT is really good at building solutions to things that we know we understand and can prioritize. But data, because of its evolutionary nature, needs to be separated from, made external to, and precede system development lifecycle activities. Or even more succinctly, data management and systems development must be separated and sequenced. One of the reasons this has also been problematic is because we haven't had a singular focus of what goes on in an organization from a data perspective. There's a chief concept in many organization types. There's a list of, I've got a list of 58 of these things actually that comes out of different places. The chief financial officer, of course, focuses strictly on the finance, the risk officer on risk, and the medical officer on medical matters in the process. The CFO does not balance the books, the CRO does not test software, and the CMO typically is not a surgeon in this area. And this lack of focus on data has prevented us from really getting a good understanding of how to use it in the long run. I'm calling for, and many others, a top data job. Some people like to call it the enterprise data executive. Oftentimes it's known as the chief data officer. I'm not real keen on the title chief data officer, because as soon as you start to have conversations about chiefs, other people come up and say, do we really need another chief in this equation? And that's not the conversation that you want them to have. Of course, the goal of the chief data officer is to work with the data governance organization through connections within IT and focus 100% on leveraging data assets that aren't constrained by an IT project mindset, and have that individual be reporting to the business, because the business is really the only type that can assign the value to it. And consequently, understanding that whole process is very, very critical. Now, there are 7 deadly data sins in here. I won't go through them, but there is something called data-centric thinking. We have a website called thedatadoctrine.com that explains a little more detail. Because this is a new field, we haven't got a lot of good qualified data leaders out there. Implementing a robust means of shared data is really important, and if you don't do that, of course, that's a deadly sin. Your data programming, your IT projects need to be aligned correctly. You need to manage expectations. You need to watch out for several specific sequencing things. Just the easiest one to visualize is that technology is the last thing you should talk about, and consequently the last thing you should purchase when you are making investments in data, whether it's analytics or artificial intelligence or anything else. And finally, failing to address those culture and change management perspectives are going to doom most projects as well. And speaking of doom, your enterprise data executive may also be doomed. We're finding the lifespan of about a year on some of these folks, and it's kind of tough. So how do we get to the last part of this? Well, what we really want to talk about is thinking about data as an asset. And when you understand that data is an asset and have different amounts of time and effort that are going into it, your most powerful, underutilized, yet poorly managed data asset shows up for a couple of reasons that are important. First of all, you want to improve your organization's data because data points to where valuable things are located. It has intrinsic value by itself and inherent combinatorial value. Then you want to also improve the way people use this data because they haven't been trained. And I'm not talking about the data scientists of the world here. No, I'm talking about your average knowledge worker. My definition of a knowledge worker is somebody who works with data. And all of them use data to measure change, to manage change, and to motivate change. And when you have improved your organization's data and the way people use the data, then you can improve the way your data and your people support your organizational strategy by creating a creative, competitive advantage. I'm going to give a quick story here about Rolls-Royce. It's a very wonderful company, and it has a model that used to consist of selling jet engines, but the new model that they've done, which they felt was more powerful, was to sell hours of powered thrust. They have a name for this. It's called power by the hour. And one of the provisions is that if the jet engine isn't making money for whatever airline it's in service of, there is no payment for downtime. So either the airline or Rolls-Royce are making money. Their interests are aligned. And when their interests are aligned, they can have different conversations. And one of the conversations they had were about how fast can we swap things? And they looked at that originally from NASCAR, but it turns out it's a Formula One example.
Time to refuel and change tires. Newmore himself changes the tires. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. The tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stops.
So our measure there is 67 seconds to change 2 tires. And the measure here was 4 seconds and 4 tires. See, if they can get the engines off the plane faster, they can make the planes go back into service faster. And that's good for American Airlines or whomever, and it's good for Rolls-Royce. Now, the real question at the bottom of this was, when was this technique invented by Rolls-Royce? Well, it turns out they celebrated their 50th anniversary of Power by the Hour in October of 2012. This required an enormous amount of changes in a very, very immature technology organization on here. It serves as a good reminder of the 7 deadly sins and how they have to be overcome in order to actually make all of this work. Now, the process of actually getting this to work is based on something that many of you have heard. It's a book called The Goal, which talks about the theory of constraints. Theory of constraints simply says that there's one way to identify the chain being no stronger than its weakest link. Now, that one thing is the one thing you want to focus on, fix it, and move on to the next one in there. It's very broadly applied, and one of the ways of applying that is to do something along the lines of speaking in terms of language. So one of the groups we worked with had a very interesting way of describing their process of getting data. It was very painful, and they used to say, oh yeah, it's just like that Catherine Zeta-Jones movie that was so hard for us to utilize on that. So using their language is very, very important and appropriate on this. And they, at Catherine Zeta-Jones movie, man, they understood that, and that was the thing that they wanted to make sure that management understood. They did not want to have to go through that much trial and tribulation in order to get their data. Because while it's a good prize at the end, it still is way too much effort that you don't want your organization really getting good at this. Now, get back to that slide. There we go. Another component of all this, we've done some things at VCU that are kind of proud of too. We've got a program called the Data Interns Program, where we get big data sets from the Commonwealth and make use of them. And a lot of people are finding this model useful because there's a surprising supply of students and state-run data. Talk more about that offline, but it's a program that's certainly worth looking into. Another really interesting project we did, we were at a Fortune 500 company or 450, whatever it was. We're doing something completely different, but I found this room of 100 associates, and I asked the question, what are these guys doing in there? Because it kind of looked like a fairly sophisticated operation. They said, oh man, we are manually correcting every item on every customer invoice. We're talking about the customer's name was wrong, the date of service was wrong, the amount of service provided, the amount of service cost, all of these things were incorrect, and they didn't want to go out and embarrass themselves. So we pointed out to them that there was probably ways of fixing this that were better, more effective than having, really a room full of 100 people correcting this. And the responsible manager actually came back and said, well, I don't know, I don't change anything. This best quarter, best year I've ever had. I'm thinking about maybe I need to double the number of people in this room in order to make this work. Now, the point here was walking down the hall and talking to the CFO and pointing out that that entire company could increase the return on investment, the time to market, the cash flow on $9 billion annually. And if it could be done for less than $800 million in a month, it was probably a good positive return on investment there. One other example here real quick, a knowledge worker. Think about this for just a minute. Why should a knowledge worker with a Ph.D. in chemical engineering have to know whether FoxPro is Y2K compliant or not? And what the heck is FoxPro? So this is a big international chemical company. They develop and manufacture additives for fuels, which means when they find something that they're ready to go down and test, that'll help the engines burn smoother, cleaner, longer, faster, better, cheaper. They go down in the basement, they turn on the engines. They run tens of thousands of tests on these things annually, and these tests cost up to $250,000 a piece. Now, these all folks, about 100 of them, had PhDs in chemical engineering, and we're just going to put a easy number on it and say that they each get paid $100,000, so the entire investment in this 100-person room is $10 million annually. Now, we did this chart for them, and they immediately said, whoa, you guys have done a great job, you're done, right? And we said, well, no, this is just our diagnostic tool of understanding how it is you guys do the work. And they said, oh, well, we've never actually understood it ourselves, so this is very useful. Thank you very much. We said, well, that's nice, but we wanted to point out a couple things. First of all, you have people here who are getting paid $100,000 a year who are manually transferring digital data between computer A and computer B. Pretty sure any of them, if they thought about it, could do a better way of doing that. Second one, they're using USBs to move data around. This is problematic, of course, because most organizations, if the USB is the only copy of the data, can only have it exist in one place at one time, not to mention the risk of losing the data along these lines as well. There's also several manual data manipulation steps on here, which are unfortunate because it shouldn't have to occur when we could actually impose something like a macro on this process. Synonym reconciliations here, again, different people using different vocabulary that had to be re-examined at the end of the process to make sure somebody hadn't stomped on somebody else's work in that way. Tremendous number of tribal knowledge requirements here where these macros or programs were hidden. Nobody knew how to get at them and affect them. There was certainly no documentation on it. You just had to know. And finally, of course, they were using FoxPro, which is not a product that they ought to have been using given the circumstances that they were under. Non-sustainable technology in here. Now, the real fun part about this was after we put it all together and helped them reduce the expenses and get their time to brilliant new products faster, they told us they expected to realize a $25 million gain in the productivity thanks to these improvements that we had made in their organization. This was a phenomenal result, and if I had made the number up, you guys might have doubted me, but the customer says this is true, so we will give them credit for it. Finally, one other piece of this was the Defense Logistics Agency, and they had a project where they were dealing with millions of NSNs or stock keepers units, 2 million of them total in the catalog. And for some reason, the data had migrated to a clear text field, a comment field. So we were asked to come in and develop what we call a proprietary improvable text extraction process. Truthfully, we would call it text analytics nowadays because it sounds a lot sexier, but you get the idea, to convert some of their non-tabular data into data that was more tabular. Now, again, we use these words instead of calling unstructured and structured data, because truly, if something is unstructured, the definition is you can't add structure to it. So you may be able to convert semi-structured data into more structured data, but our better language is to say non-tabular data into tabular data. And I like this particular project. I love to talk about it because it's the first time I had saved $5 million, or more importantly, a person century of work. Now, when you're determining the diminishing returns on a project, one of the most important things that organizations forget is that the entire solution is probably a blend of human and automated capabilities. And most organizations, and particularly those that are involved with algorithm-driven focuses, is that they try to get everything accomplished by the algorithm. And that is not generally the best way to go. So just to tell the story of this particular project, the first couple weeks we were on it, we didn't solve much of it. By the time we got to the fourth week, we'd solved half of the problem. Question, should we stop there? Well, that depends. If the costs exceed the benefits, then yes, we should stop, or are projected to exceed. But we'd also in that time learned that about 12% of the data was completely ignorable, which left our problem space down to about a third of what the overall problem was. And making good rational decisions based on a fixed side on the left, which is just to say that it was the price of 2 of our data engineers working a full-time week between the 2 of them, so a very fixed cost. Let's make a ridiculous number up and say it was $10,000 a week. I'd love to get paid that, but believe me, the market doesn't work that. Although, as you've seen, some of our work is that good. Anyway, back to the focus here. 10 more weeks of work for week 4 to 14, we had now taken the entire problem space down to 9%. This is where the customer said, if you could get one more class of data, one more type of SKU information out of this big, massive data set that's here, we would think that would be worth $100,000. And so we said, great, so we'll put a time limit of 10 weeks on it, and if we haven't solved it by then, we'll stop. Well, you can see here, we got down to week 18, just 5 more weeks beyond this, and all of a sudden we had found that last little bit of information. So for $50,000, we solved a $100,000 problem, and more importantly, I'll show you the bigger numbers here next. Again, 22% of this data was completely ignorable, and we had solved 70% of it. Now, I don't know about you guys, but that was the original size of the problem, 2 million NSNs, and here was what had to be done by hand afterwards. And given everything that's gone on, I'd certainly rather work on the smaller pile instead of the larger pile in order to do that. Now, we can quantify these benefits by taking 2 million NSNs and times number of hours per week and the working hours in a day. And this 96.2 that you see here on the screen, a little up from the bottom right, is my person century I'm rounding up, okay? And there's my $5.5 million here at current rates. Now, we wrote this up into an article, so there's lots more data here if you'd like to read more about it. But let's just replace these numbers here now with the numbers that we use in the revised project total, 150,000, which means our total cost down here is 7 years and less than $500,000. So there's my $5 million in savings. Of course, the real key for this, you want to do a little social engineering here if you can, is to say, what is the most important number on that slide? And the answer is 5 minutes. The actual time is closer to an hour. And if somebody were to say to you, let's change that number to an hour, you can see that these numbers become very, very large very quickly. One final example here of just something that operates on a real nice automated fashion with good quality data going in is the Apple Automated Customer Online System. A customer makes an order of an iPhone, they get an acknowledgement very quickly, and then Apple says to their assembly partners, make me one more of those and send it to these folks. Great piece. They never have zero inventory that's on there. It's a wonderful way of doing business. And wouldn't you like it if you could get 8% of your revenue, or about a business of $16 billion, to work that well? So these have been some examples of organizations that really understand how to use data as an asset in here. And through this talk and others and other types of education, I'm hoping that everybody's coming to the conclusion that IT and the business need to both work more on data, because right now most people think of it as sort of this thing, the bat sign there that's between data and the business, whereas in reality it's much bigger. And if we get to this level of understanding, that's great. The actual, of course, way the world works is that there's the way it really looks. Data is becoming ubiquitous in our approach to this. I like to finish off here with a quick little example of showing non-valued productivity, but unfortunately it's too true in organizations.
With my balls. They're like, I love that was a girl. All right, here we go. A tribute.
Oh, we will start that one over again. Just to let me know if the background music was silly or not.
You know, anybody can play the piano with their fingers, correct? I learned to play with my balls. They're like, I hope that was a girl. All right, here we go. A tribute.
Oh, so I'm still here. All right, so what happened is I want to show that because that's how most organizations are doing their data management. They've learned to play piano by throwing pink balls at it. It's not the most efficient way of doing it, and it's certainly not everybody learned the same technique. So in order to get your data this way, you're going to have to do more with it by putting more investment into it. Taking your data from detritus to a resource to an asset is a journey that most organizations are trying to do, and one we hope everybody can get to. Thanks for your time.